Hello, welcome to the video where I do the activity called Desperately Seeking Sadness, which is going to be a deeply metaphorical game using the Phaser 3 game engine. So let's get going. As always, I'm going to talk about what I'm thinking, and I'm probably going to make some mistakes, and it's going to be a hell of a lot of fun. So here's the activity description. I'm just going to go through this step by step and build this thing. And you can follow along, pause me when you want to kind of do the things yourself, and unpause me to see what crazy hijinks I got up to. So the idea that I have here is that we're going to have a kind of physics simulation of that thing that you get sometimes where you're kind of drawn to negative feedback or negative emotions, even if you're maybe surrounded by positive things and positive emotions. And that's going to be in the form of a spaceship that's flying around in this kind of asteroid field of positivity, desperately looking for the one piece of negativity, the beautiful unobtainium of negativity in the galaxy. Anyway, it's going to look something like that. So let us begin by creating a new project, as it says here. So I'm going to download the plain JavaScript project and rename it to Desperately Seeking Sadness. I can do that. I'm a competent person, so I've downloaded it. There's a general student request on my desktop I'm going to remove, and I'm going to expand that zip file and rename it to Desperately Seeking Sadness. And then, of course, I need to copy it into my activities folder, which is right there. So it's in my repository under activities, Desperately Seeking Sadness. Clearly, the next thing I do is I open it in Atom. Perfect. And clearly the next thing I do, I don't even need to check, is I should change the title, because you shouldn't have a title that says change this title in index.html. Desperately Seeking Sadness. Wonderful. Now, what else do I have to do in these things? I've opened it, I've changed the title. Add Phaser 3 to the project by adding the appropriate script tag from the CDN. So I'm using the CDN. As you know, you can also download the file. But I'm going to click through to download and get started. I'm going to click on download Phaser from GitHub. And I'm going to scroll down to the CDN to get the phaser.min.js script tag. Copy that and head over into my index.html and paste it in the library scripts area. So now Phaser is available to my program, which was the objective there. Commit the changes to your repository with a commit message. I'm going to skip that one. I suspect that my repository just looks like complete trash, but you should absolutely do that. It is the right thing to do, and you should really keep your repository nice and tidy with regular commits. That is actually what I do with my other projects. I have not done a good job with my fake cart263 repository. Okay, what's the plan? So the plan is to first of all set up a basic kind of Phaser 3 project. We've looked at that in the lessons that come before this activity, and I want to replicate that because it's so important. Then we're going to create an avatar sprite. We are going to add keyboard controls to that avatar sprite, but this time it's going to be like it's a spaceship, so it rotates and kind of accelerates forwards. Then I'm going to add a thumbs down sprite, which is going to represent negativity. Then I'm going to make it so that the avatar can collect the thumbs down, so it's like you can get it. And then I'm going to add a whole bunch of positivity in the form of thumbs up sprites that are going to be everywhere in the galaxy of positivity. So let's do step one. This is kind of the sort of thing that eventually you would build your own kind of template, so you don't have to do this every time you start a project, but it is a good idea to review just the steps that it takes to put together a Phaser 3 project. So let's follow the instructions. The first thing I'm going to do to follow convention is rename my script to main.js. You don't have to do this, and it doesn't make a difference per se, but I prefer to follow the dominant convention. So I've renamed it to main, and I need to rename it in the script tag as well so that it is still linked correctly. So that's step one. Step two, I'm going to add a boot.js file and define the boot class, which extends phaser.scene. So this is our preloader, right? This is the thing that's going to load any image assets that we have in our program. So let's go ahead and do that. So back in Atom, I'm going to add a file to my JS folder called boot.js. And I'm going to define a class called boot, which is going to represent the preloader, which is a scene, and it's going to extend phaser.scene so that it can do all of the magical things that a phaser scene can do. That's important, otherwise we're not really using phaser. Add a constructor that calls the super constructor to set the scene key to boot. Okay, so whenever we make a scene in phaser, we need to have a constructor, just because all classes have one. But the only thing it needs to do is call the super constructor with an object, and that has at least one property, which is to give it the key, which is the scene name, basically, that we'll use when we're switching between scenes, for example. So at the bare minimum, we need to do this so that the scene knows what it is called. Add a preload method that includes a listener for the loading, complete event, and switches to a scene with the key play. Okay, that's a little bit more sophisticated. So I need a preload method. In that method, we know that we're going to load image assets, right, or other assets. So load assets here. But then at the end of preload, we want to add an event listener that will switch to the play scene when everything is loaded. So how do we access that? Well, we know that there is a load system in Phaser that we can use to talk to the loading system. We use that for loading the images and so forth as well. But we can also talk to it by adding event listeners. So this.load.on, and the event that I want is called complete. And when it is complete, I want to call a function. The function I want to call, I'm going to make an arrow function. And I'm going to do that because I want to use this inside the function to refer to the scene that I'm currently in. Because what I want to do is switch to the play scene, and I do that with this.scene, which is the scene management system, .start, which tells it to end the current scene and start a new scene. And that scene is going to be called play. I haven't created it yet, but that's what it will be called. So again, the arrow function thing here that I'm using is a nice, tidy way to be able to continue to use this to mean the same thing that it means in the rest of the preload method and in this class. It's a classic use of arrow functions. It's also just kind of neat and tidy because I only want to run one line of code when loading is complete. So it makes sense to use an anonymous arrow function in this particular situation. So there we go. We're ready so that it will switch scenes when we begin. Just out of good form, I'm going to also add a create and update method. Even though I'm not going to necessarily use them right now, it always makes sense to have them in any scene, just because they're the fundamentals of how a scene works, right? At a bare minimum, you would have a constructor create and update in any scene for it to do what it needs to do. And in this particular scene, we have preload because it's a special scene that is the preloader for the overall game that we're making. Okay, continuing with our little skeleton, we're going to do kind of the same thing, right? If you look at this, the same thing except for a play class. The big difference is it does not have a preload method. It doesn't need one because that's all taken care of in boot. So in the spirit of efficiency, I'm just going to duplicate the boot.js file into a file called play.js. And I'm going to go ahead and rename the class to play. I'm going to set its scene name key to play. And I'm going to delete the preload function because we don't need that. And then we've got our very, very basic kind of skeleton of a phaser scene. So constructor, create, and update. So now we have play and we have boot as classes that are defined to represent phaser scenes. We also need script tags in index.html so that our program knows that they're available. So let's go over to index.html and add those. We would add that with our main script. I'm just going to duplicate that line a couple of times and add boot first and play second, just because that's kind of the order that they belong in, right? The main thing is that they need to be before main.js. So now my HTML links to my scripts. The final thing that I need to do is actually use all of this stuff to create a beautiful new phaser game. So I need to add the configuration object for my phaser game and then create that game. So let's go ahead to main.js. While I'm here, I will say desperately seeking sadness and add my author name. an emoji in search of satisfying sadness in a world of positivity. That's kind of the movie tag. Obviously, I should write more in here that describes the program, but I don't want you to just have to sit there watching me do that. So we need to create a configuration object. So I'm going to call it config. It's a classic name. And in here, we're going to have the properties that we use to set up our phaser game. I've listed them here in the instructions. So we want the type to be phaser.auto. That's so that it will choose to use a standard canvas or the WebGL canvas, depending on the computer that this game is running on. We want to specify dimensions of our canvas. So width, I'm going to set to 800, and height, I'm going to set to 600. That's sort of fairly obviously named properties for that. We want to include arcade physics. So we're going to be using physics, so we should tell the game which physics engine we want to use. And to do that, we have a physics property, and that gets its whole own configuration object. Because you can set a bunch of properties on the physics engine, you can set them all in this one place. In this instance, all I want to do is set the default physics engine to the arcade physics engine. There are other things. You can set gravity and so forth in here as well if you want to, but all I'm doing is setting up the default. And finally, right, and then we need the scene property. So the scene property, which should really be called scenes in this instance because I have more than one, contains an array with a list of the classes that represent the scenes in your game. So for me, that's boot and play. It's important that the first one is the one that you want to load when the game starts. So that should be your preloader generally. And then the other ones, the order doesn't really matter because you're going to be controlling the order that they load in yourself. So that's a very good basic configuration of a phaser game. Now we need to create the game. It's sort of polite to actually assign the game into a variable rather than just let it be lost in the ether. So I'm going to create a variable called game, and I'm going to assign it a new phaser game, and I'm going to pass it the configuration so that it knows what to be when it grows up. And then we have our skeleton in place. So if I run this with good old Atom Live Server, which I just did, we get a big black rectangle, which is the game. It has a default background of black, and we're not doing anything, so it's not doing anything, and that is completely fine. So let us return to our activity and find out how to actually make this do something. Add an avatar. So if I want an avatar, I'm going to need an image to represent it. And I am going to have a neutral face emoji to represent the avatar. So I'm going to download the neutral face here. I'm going to use Apple's one. I could use any of them really. It doesn't matter too much. Hopefully I won't get sued. And I'm going to call this avatar.png. Oh, added one extra PNG in there. And as it says over here, I can close that now. We want to resize it to 32 by 32, so it's a bit little. Rotate it 90 degrees clockwise. We will talk about why a bit later on, and call it avatar.png, and then put it in the assets images folder. Okay, so there's a few tasks. I need to resize it and rotate it in particular. So I'm using the Mac Preview app. You can obviously use whatever you use to resize things and rotate them. So 32 by 32, little, and rotate 90 degrees clockwise. Oh, save. It's very cute on his side there, or their side. So now we've got our little image. I can go into Desperately Seeking Sadness, Assets, Images. Naturally, there's a clown lurking in there, and I can copy the avatar in. So now the file is in the file structure of my project. Now I have the two basic steps to make this a part of my game, which is that I need to load the image in my preloader. So I'll go and do that first. So I need to go to boot, and I need to go to preload. And here, to load things, I say, well, to load an image in this instance, I say this.load.image. I give it a key name. I'm going to call it avatar for when I refer to it later. And I need to give it the path to the file, which is assets, images, avatar.png. That will load it. So now the preloader has something to do, which is kind of nice in the first place. And then in play, I need to actually add a physics sprite that uses that picture. So I will go to play. This is something I would do in create. Create the avatar. This.avatar. So I always want to assign this sort of thing into a property of my class so that I can refer to the avatar at other times, and when I want to do things with it is assigned this.physics. Remember to use the physics system. .add. This is the thing that we can add things with. I could either use image or sprite because it's just a single frame. I'm going to add it as a sprite. I just prefer to think of things explicitly as sprites. And I give it a position. I'm just going to say 400, 300, and the key name that it's going to use for the image, which was avatar. That's what I called it in boot.js. So with that, assuming I didn't make a mistake, which is, well, we'll see, I should then see, wonderful, my little kind of like not sad, not happy, just kind of dealing with it face, rotated 90 degrees clockwise, sitting here on my canvas. So I have the thing that I'm going to be steering around when it comes to it. So the next bit that we're going to do is a wonderful piece of taking somebody else's code and making it our own, because spaceship input, where we sort of steer by rotating and adding thrust, is just something that it's not really worth writing ourselves. So instead, I am going to go to the phaser examples and get a nice little example of this kind of controls. I happen to know that it's in the physics examples. It's not really clear to me that that's the right place for it, but it's in arcade physics, and it's an example called space. So it's down towards the bottom here. Where is it? There it is. So this is one of the things where you just kind of see these things as you're browsing around in the Phaser 3 examples. You find things that kind of you can think of, and they have little components that you want. So here, for example, we've got a little spaceship. It rotates, and when I push up, it flies a bit. Wonderful. For some reason, there's drag in space, so it also slows down and stops, which makes absolutely no sense, because that's not how space works, but that's fine. So looking at the example, of course, it's more complicated than just the thing that we want to do, so we kind of need to search through here and find the pieces that we need in order to actually get access to this stuff. You can see there's a whole lot of stuff in here. It's like there's quite a lot to look at here, but you can see here, for example, it's talking about a bullet, which I don't actually care about. There's the bullets update. Then there's a whole lot of adding stuff. There's a lot going on here. There's adding images, which is fine. Then there's a big loop that's doing stuff. I guess that's adding the particle effects. Then there's the ship, which is kind of equivalent to our avatar, right? That's the thing that moves around. You can see actually, just by way of example, here's the reason that it slows down over time is that it's got a drag. But here, and this is just something to remember, and we looked at this in the lessons, here is the line where they get access to the user's arrow keys. So let's copy that line and use that in our create, because we want to be able to access the user's keys. The one difference that we will have to, the one change we'll have to make here is because we're in object-oriented programming, we won't just call it cursors like a variable, we'll call it this.cursors and make it a property of the scene so that we can access it everywhere in our class, which is more appropriate in this particular case. So it's using the input system's keyboard system to create access to all of the different cursor keys. So that's part one. I'm just double checking. Right, so that was the first bit. And then in update, we need the actual code that they're using to move the spaceship around. And we can find that fairly easily. It's this stuff here, right? This is dealing with the left and right arrows and setting angular velocity, which is to say turning velocity. And this is to do with using the up key to actually set the forward velocity of our, or acceleration of our ship, in quotation marks. So I'm going to copy this stuff and paste it into my update. But again, this is not going to work the way that it is, right? There are a couple of big differences here. One is that it's not called cursors. It's called this.cursors, so I need to make sure that I correct that. This is a classic thing that we have to do when we're reusing code from somewhere else. Very rarely does it actually just fit without any modification, so we have to pay attention. The other big thing is that they're constantly talking about the ship that they are controlling, but we don't have a thing called ship. We have a thing called this.avatar. And so that's what we want to apply all of these ideas to. Now looking at it quickly, we can see that if the left arrow is down, then we're going to set the angular velocity of our avatar to negative 150, which will turn it anti-clockwise. If the right arrow key is down, we're going to set that angular velocity to 150, which will turn it clockwise. And if neither of those things are true, i.e. neither right nor left is down, then we're going to set the angular velocity to 0 so it stops rotating. The other part of this is forwards movement. So when we press the up key, we use this one very nice physics method called velocity from rotation that changes the velocity of our avatar based on its current rotation and this number here, which is like how sort of thrusty the movement is. I'm going to make that a little lower because I find that it was moving a little bit too fast for my liking. So let's go take a look at whether that actually worked. So here's our game. So can I rotate? Oh, yes, perfect. So avatar rotates when I hold down the arrow keys, and when I press up, the avatar accelerates. And it's kind of got this big loopy movement. I could spend a whole bunch of time kind of trying to work on the physics of this, but I'm not going to. It doesn't interest me right now. You can see that the avatar is kind of going off the canvas, which I didn't really think that we wanted. So let's also set its collide world bounds to true so that it doesn't go off the canvas. We should do that when we create the avatar. So this.avatar.set collide world bounds is true. That way, when we steer around, it just hits the walls and sadly subsides to the bottom right corner. That's super cute. I feel sad, but also amused by that image. There's something very poignant there that you could probably take a fair distance design-wise. Okay, so that's now working. Oh, and just to point out, right, that if I reload this example, the reason we rotated the avatar 90 degrees clockwise is because that's the direction it's kind of facing by default in the physics engine. So if I just push up without rotating, it moves to the right. That's the reason I wanted to rotate the images, so it's kind of aligned with the way that the physics system is actually working. So you fly towards the top of your head, which, you know, as everybody knows, that's how emojis fly. If you didn't know that, I guess you learned something today, which is great. Okay. So we've done that step. Now we want to have the unobtainium of our game, which is this thumbs down that the avatar is going to be able to fly into and collect. So we're going to go get the thumbs down emoji and apply the same kind of process, except that we're not going to rotate it. So I'm going to grab thumbs down here. Going to rename it to thumbs down, which is an incisive name. I'm going to open it and I'm going to resize it to 32 by 32. That's my kind of size for things. And then I'm going to move it into my project, thumbsdown.png. Okay. Then I need to do the same thing of loading it in boot.js in just the same way as the avatar, right? This.load.image, except I'm going to call it thumbs down, and it's in assets, images, thumbsdown.png. So that's another thing that my boot scene can load for me before play begins. And finally, I want to create my physics sprite, but this time I want to create it at a random position. So I'm going to, first of all, I'm going to create a random position on my canvas. So let's do that first. So I'm going to say let x is assigned. There's different ways of doing this. I'm going to just use math.random. Math.random times this.sys.canvas.width. That's how I can get access to the width of my canvas as a number. Same thing for the y height. And then I'm going to add a physics sprite, which is going to be called this.sadness. That's the thing that we're all after in this life. Physics.add.sprite. And now instead of numbers here, I'm going to use the x and the y that I just created for the position. And I'm going to give it the thumbs down image to display it. And so now we've added a second physics sprite to the world of our game. Let's go check that out. There it is there. Thumbs down. And if I reload, thumbs down, thumbs down. So it spawns in a random position, which is what I desired. Okay, so we've done that. The next thing we want to do is we want to be able to collect it, right? Because right now, if I fly into the thumbs down, shoo, bunk, bunk, nothing happens. So you're probably immediately thinking, well, we need an overlap check, and you are right. So let's add an overlap event listener, checking for an overlap between the avatar and the thumbs down sprite, singular, Pippin singular, and we'll write a method to handle that called getSad. And we will remember that we want to worry about the meaning of this. So this.physics.add, and we're going to add an overlap between this.avatar and this.sadness, and it's going to call a method called, I don't know, getSad. And then we add those extra two arguments, null, because we don't want to add yet another method to handle that overlap, and then this, so that we're telling it to use the scene as the context when it calls this this.getSad. Then we can define getSad. We know it's going to be passed two parameters, the avatar and the sadness, which are the two things that were involved in the overlap in the order that they were provided here. And rather than destroy the sadness, which because nobody can truly destroy sadness, we are going to put it in a new random position. So I'm going to grab the x and the y here. I guess I should have, in getSad, assign a new random position. You can reuse the earlier code. Yeah, I should be going a little bit slower. So I can do the same thing, right? I can generate a random position here, and you can probably think to yourself, well, this is not very good because you're copying and pasting code and creating duplication, and you are right. And we would look at that when we were improving this program. And then I can set the position of the sadness using setPosition again here. So set position x and y to move to that new position. So now we've got our overlap. The physics engine will check when the avatar overlaps the sadness and move it to a new random position with this getSad method. Let's go and make sure that that's working. Oh, it's all the way down at the bottom there. Let's go get it. Look. Oh, there's something very nice about sliding along the bottom like that. So it's working, right? The overlap is triggering. It's calling getSad, and getSad is moving the thumbs down to a new position. It's unclear metaphorically whether this means that my little person is getting the sadness and there's a new one, or whether the sadness is kind of elusive and you never truly get the sadness that you desire in your life. That's something to clarify later on in design. Okay. There's one more thing that I wanted to do with this program before calling it a genius masterpiece, which is I wanted a whole bunch of thumbs up sprites, and that there would be kind of this field of them all over the place, and they're kind of in the way of our avatar, which is, you know, trying to get sad, but there's all of the stupid positivity around that's kind of preventing them from getting there easily. So let's do that. Clearly we're going to use the collision system of Phaser 3. And arcade physics, but the first thing, of course, is yet another image. This time the thumbs up emoji is going to be the one that we want, and we're going to perform the same series of transformations. So there's a thumbs up onto my old desktop, rename it to thumbs up, open it, resize it to 32 by 32, save, and move it into my project. I probably could have just flipped thumbs down to make this happen, but I didn't, and here we are. I think there's some usefulness to having two separate files representing these two elements. It makes them easier to replace, for example, if I need to. Okay, so we've got that. Then, of course, in boot.js, we have to load that image. This is like a classic process. We can duplicate this line because it's literally just replacing down with up. So we've got our thumbs up key and our thumbs up file. And then here, we're going to create a lot of thumbs ups. So the way that we're going to do that is using group-based creation. And this is a very nice way of doing things. And indeed, there's an example that I want to just go and look at called group versus group, which is in the Phaser 3 example set under arcade physics. So I'm going to go to physics, arcade, and group versus group. Where are you? Hello? I mean, it's alphabetical, so I do know where it is. I just need to find it. There we go. So this is going to give us kind of the idea, right? There's all of these things, and they're all moving around and bouncing off of each other. And really what I want is the lots of things and the bouncing. So let's go and look at what they did to do this. So the thing that they did, which is nice, is this. So they added a physics group, and they had a key, which is the image that it was going to use, a quantity, which is how many, they've got 24, and then they also use a couple of other things in here. They've got bounce X and bounce Y, that tells you how bouncy a thing is, collide world bounds, which keeps the thing on the screen, and then they also set a velocity. We don't really want to do that because we don't want our thumbs ups to be moving, or I don't anyway. So let's follow that idea in our own code. So we've added our sadness. Let's add our group. So this would be the happiness group. I'm going to call the variable I assign it to happiness, and I'm going to assign this .physics.add group, and then I provide the configuration object that's going to tell it how to make all of the elements in this group. So first and foremost is the key. It's going to use the thumbs up sprite image. The quantity, how many do we want? I don't know. How many do I want? 120. That seems like too many, but let's see what happens. 120. And then they had a couple of other things, right? They had bounce, which is kind of interesting. So I like the idea that the thumbs up is bouncy. That kind of fits. That kind of fits with the idea of happiness, that it's bouncy. How bouncy? What do they have here? Bounce. They got one. One means completely bouncy, like it retains all of its velocity when it bounces, or all of its speed, I should say, or momentum. I'm going to make them 0.5 bouncy in both axes. And then they also had collide world bounds. I think that makes sense for our things as well, so they don't go flying off into the ether regions outside the canvas. So collide world bounds is true. And there's actually another one that I want to add in, which is drag. So drag X. We can set a kind of deceleration effect that affects, and we saw it with that spaceship that we were looking at earlier, the idea of drag. I'm going to say that they decelerate by, I don't know, 50 pixels per second over time. And I'm going to set that in both X and Y. So that gives me a whole set of thumbs up, 120 of them, that are bouncy, that hit the walls of the canvas, and that slow down over time if they start moving. So what does that look like? Looks like this. So again, we've got that thing where they're all in the top left-hand corner, right? They're inside the canvas because when it got positioned right on the edge, it collided and ended up back inside the canvas. But that's not actually what we want. However, group versus group has another great thing in it, which is how they position all of the elements that they're putting on the canvas, and I want to take that because it's so damn nice, which is this thing here. So Phaser has this category called actions, which just has these sort of tools that do useful things, and one of the things it can do is it can position a whole lot of elements randomly within a rectangular area or a circular area, or it can position them in a grid. There's lots of good stuff in the actions category. It's really worth looking at. But in this instance, you can see what's happening is it's positioning all of the children of the balls group in this instance, and it's positioning them inside a random, it's positioning them randomly inside a rectangle defined by this.physics.world.bounds, which is the area of the physical world of the game, which is the canvas. So it's kind of perfect in terms of what we want. So I'm going to use it immediately here. But obviously, instead of balls here, I want this to apply to all of the children of the happiness group. So we're saying get each member of the happiness group, all of the children, and put them in a random position somewhere inside this rectangle here. And this rectangle is the physical world of the game, which is the canvas itself. Let's go look at what that does. Oh my goodness, that's a lot of thumbs ups. So now we have what we wanted, which is there's the thumbs down, which is nice. But as I fly around, we've got all these thumbs ups. But wait, what's going on? Why aren't they hitting each other? What's going on here? This is not working. They're not in the way, right? So there is another step, of course. We want collisions. So we want to add a collider so that the avatar hits the happiness group and bounces off them and so forth. We actually also want a collider between the happiness group and itself, and that's so that all of the thumbs ups interact with one another. So let's add our colliders down here. This.physics.add.collider. And then we say, what do we want to collide? Well, I want the collider to pair the avatar and the happiness group so that they hit each other. So by adding that one line, now when we go look, the avatar bumps into these things. Look at them. They have a bit of drag. They stop moving. They're in the way. They're super irritating. And then, oh, good. Got the thing. But we also, it would be nice, currently the thumbs ups go through each other. It would be better if they hit each other. And so a thing that you can do, which is nice with groups, is you can add a collider between a group and itself. Comme ça. And that's basically saying every member of the group should be able to collide with every other member of the group. Not with itself, obviously, because that doesn't make sense, but it takes care of that whole idea, which, you know, you can imagine all of the for loops that are involved somewhere deep within Phaser 3. But now they collide with each other as well, so it's even more irksome to try and get through them. Maybe too irksome. Oh, I found it. But you can see, like, my little face is having a much harder time getting that sadness that it so sorely needs. Ugh. It's like a demolition derby for sadness. So there you go. We've actually finished this little simulation of seeking out negativity that I was so excited to build. And I guess you could also make the thumbs down be bumped into by the thumbs up. That would make this even more irritating because it would get moved whenever they were moving. So I didn't think of that. Let's throw that in as well. So let's make the sadness also collide with the happiness. That's starting to get very deep and poetic, I would say. So there's the thumbs down. So now I guess if I bump something into it, I'm too incompetent to bump anything into the thumbs down, apparently. Yeah, that's for some reason I'm finding that difficult. I want to make it happen, but now it's like I'm trying to do this on purpose, like a sheepdog or something. There we go. There we go. Up. Come on, Pippin. Fly your spaceship. Yeah, there you go. You saw it move. It happened. There we go. So we've got our beautiful metaphorical game. There are, of course, improvements to make in terms of improving the random positioning, moving the control stuff in update into a separate method, and so forth. But we've really got a nice little framework here that we could use to expand on and make quite interesting, strange experiences, especially if we added new elements to it, added different kinds of interactions, fiddled around with the physics parameters, and so forth. We can really we can make something quite intriguing out of this. So I hope you've been following along and that you've got more confidence with the Phaser 3 physics engine now. It was a pleasure talking with you, and I'll see you next time.